So today's main focus is to look at word problems involving these absolute values. So if you notice, this absolute value function is flipped upside down. Nothing wrong with that, still an absolute value function. Okay, so it says, Sandy takes a hike on a 6-mile trail. Apparently we really like hiking today. She hikes from the beginning of the trail to the end and then turns around and follows the trail back. The graph shows her distance from the start of the trail after X hours. So first off, it says after X hours. So I'm going to label down here as hours, right? And then we have to think about the Y. The Y is talking about distance, but we need to be specific on how much of the distance, right? Well, this is all about 6 miles, so this should be labeled as miles. Now again, this says that she goes all the way to the end and then turns around and comes back, which means up here is the end, right? She gets there, she hikes the 6 miles, then she turns around and goes back. All right, so we actually just did letter A. It says label each axis accordingly on the graph for this scenario. So we're all done with this one. How far does Sandy travel on her hike? Okay, well, we have to think about how far. So this is talking about your Y values, right? And it doesn't say what's the longest distance. It says what the whole thing is, right? So she goes 6 miles there and 6 miles back, which gives me 12 miles. Now, how long is her hike is talking about the hours, right? If we focus on the X's, it starts at 0, 0 and goes to 4, 0, which means it would take 4 hours. Describe a reasonable domain for this scenario. So this is talking about domain. Again, this was from Unit 3. Remember, these are your X values. So my domain here would be from 0 hours to 4 hours, right? It starts at 0, the timer starts, and then it stops at 4 hours. Describe a reasonable range. Remember, range is talking about your Y values. So our lowest Y value is 0, or 0 miles, and our highest Y value is 6. Don't let that confuse you with the 12. She did 12 miles total because 6 there and 6 back. But our actual range would be 6 in general, focusing on our graph, right? Highest point on our graph is at 6. Notice how these are both brackets. That's because these are included. You do start at 0, 0. You start going 0 miles and you start with 0 minutes, okay? And you go all the way to 4 hours and you go all the way to 6 miles. You don't stop right before it, so you do actually achieve those. That's why they are brackets. Over what hours, aka X values, is Sandy increasing her distance from her starting point? Okay, so increasing would be kind of like a positive slope, right? And the positive slope is going to be from 0 to this point up here, right? Now, notice how it says X values. You are always talking about X values when you're talking about increasing and decreasing. So on this one, it stops at 2. So it is increasing from 0 to 2. Notice how I have parentheses here. These are parentheses because if you think about it, you're not moving yet if you're on this spot. And when you're right here at 2 hours, you're no longer going up, but you're no longer going down. You're at that standstill, so you can't be positive and negative. You're just kind of stopped. So that's why it's always going to be parentheses. Okay, anytime we're talking about increasing and decreasing, always X values, always parentheses. Next one, it says over what hours is Sandy decreasing? Well, decreasing is the other part of the graph, right? This is where it is decreasing and going down. So that's from 2 to 4. So we're going to do a couple more examples like this, and we'll move a little quicker on the other ones. So this time we're talking to Jay, who is riding a boat from his home to his friend's house in a neighboring state. The graph of the function, and then they give you the equation, d of t equals 30 times the absolute value of t minus 1.5. This shows the distance of the boat in miles from the state lines at t hours. Assume the graph shows Jay's entire trip. Well, it says how far does J start from the state line? So you have to think about this scenario again. He's going to the state line and then turning around and coming back, right? So that means the state line is right here. So our starting point is way up here, and that's the distance that he is away from it, which would end up being 45 miles. Then it says, when does J get to the state line? Well, again, this is our state line. So he would get there at 1.5 hours. Then it says, how long does it take J to get to his friend's house? Okay, well, his friend's house is all the way over here, because he's going to the state line and then back to his friend's house. So for this one, it'll take him 3 hours, because that would be 3 right here. What is the domain for this situation? Okay, remember domain, these are x's that we are talking about. So we start at 0, we go all the way to 3. So from 0 to 3 with a bracket, because we are at 0 minutes and at 3 hours. Range is the same thing, but with our y's. So our lowest is 0, which will always be the case for these. And then our highest is that 45. Over which hours is he decreasing? So again, hours decreasing, we are talking x values here always, and you're always going to use parentheses. So we want to think decreasing. Well, it's decreasing over here. So that's going to be when your x values are 0 to 1.5. Then we would be increasing on the other portion of it. So at 1.5 all the way to 3, we would be increasing. And again, big thing, remember that those are x values. Now, in the last one, it says, what is the rate of change over the interval 2 to 2.5? So 2 to 2.5 is what is in the orange up here. And it's asking what our rate of change is. Well, rate of change is the same thing as slope. So we could do rise over run to find our answer. In this case, our slope is going to end up being up 3 over 2. The problem is when we go up 3, we're not really going up 3 because of our scale over here. Up 3 really means going up 15. That's because each tick mark is actually worth 5. So this would be up 15, and this is still over 2, but it's actually not quite 2, right? You go from 2 to 2.5, which means it's over a half. So instead of thinking about it as 3 over 2, you need to think about it as 15 over 1/2. If you divide 15 by 1/2, you get 30. So when they ask you to interpret this, we need to think about what that 30 means. Well, 30 means we are going a specific amount of miles in an hour. So this would mean the boat is going 30 miles an hour. So the next part is us just looking at actually putting together absolute value functions. Okay, so the first thing that we want to do is put together a table that is representing absolute values. Okay, so what I want you to do is just label the left side -3, -2, -1, 0, 1, 2, 3. If you plug this into your absolute value function, remember your x, anytime you take the absolute value of it, it becomes positive. So the absolute value of -3 is +3. Oops, didn't mean to do that. Absolute value of -2, +2. -1, +1. 0 is still 0, 1 is still 1, 2 is still 2, 3 is still 3. If you were to graph these, you'd get negative 3, 3, negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2, 3, 3. So if you notice, we have our V shape just like we have been dealing with so far. So if we talk about this in non-word problem format, what's happening here is with domain, okay, you want to think what values can you plug in for x that compares to the graph, okay, or what values for x are not going to be included. Well, it's going to keep going all the way to the left and all the way to the right. So in interval notation, it's going to go to negative infinity and then all the way to positive infinity. Your range is the one that's going to change with these. So we have to think about what's not included, which everything down here is not part of the graph. So we think our lowest y value. Well, our lowest y value is 0, and our highest would just keep going forever to infinity. Your vertex. Okay, the vertex is where it changes from increasing and decreasing. Okay, so our vertex is always the point where it stops and turns around. So that vertex would be at 0, 0 here. And our axis of symmetry is what is the line that cuts it in half. So in this case, the line that cuts it in half is this straight vertical line, which would be an x equals 0. Okay, this is always going to be x equals h, and you'll see that later. And then let's talk increasing and decreasing. Okay, remember there were two big things. Okay, always you're talking about your x values. Oh, gosh. And you always use parentheses. Okay, so where basically your vertex helps cut it in half. So it's going to be negative infinity to 0 is one of these, and then 0 to infinity is another. So I always start just from left to right. From negative infinity to 0, it would be decreasing. So I'll write that in the decreasing. And then that means from 0 to infinity, it's going to be increasing. These are the main concepts of our absolute value graphs.